In our tutorial today, we're going to look at the question that is on the screen, which is coming from a linear programming problems. And the question reads, Ukose company manufactures 3 types of leather belts, namely A, B, and C. The material cost for making type A is 700 kwacha, B is 520, and C is 300 kwacha per unit respectively. Labor cost are 440 kwacha per unit on type A, 360 per unit on type B, then 260 per unit on type C. Then the question continues to say, in order to distribute the belts to various parts of the country, the distribution costs are 60 kwacha for A, 20 kwacha for B, and 40 kwacha for C. Now, the company has set a 25% marginal value on cost as a percentage, as a profit percentage to be realized from each belt type, meaning the total cost of belt A multiplied by the 25% is going to give us the profit for belt A. So when you add your material cost for A plus labor cost for A plus distribution cost for A, we're going to have the marginal cost for belt A, and the 25% of that marginal cost will be the profit for belt A. We continue. To manufacture the belt, type A requires 2 parts of leather, 2 parts of fancy buckles, and 4 hours machining time. Type B requires 5 parts of leather and fancy buckle each. Then we have got 2 hours of machining time. Type C requires 10 parts of leather, 3 parts of fancy buckles, and 2 hours of machining time. So the question continues to say, a maximum of 900 leather buckles are available per day, with 400 fancy buckles available as well as 600 hours machining time available to produce all the types of belt. Now, the key word there is maximum available resources, which is the 900 for leather parts and 400 for fancy buckles and 600 hours for machining time. Now, if you look at that, this maximum available resources basically tells us the main aim of this linear programming problem. So, the aim of this linear programming problem is a maximization problem. And after you identify that it's a maximization problem, the question is, what are we maximizing? Now, take note. We can maximize the contribution per unit if the question had the contribution per unit. We can also maximize the selling price per unit, provided that there was no means for us to find the profit. But now, in this case, we're going to maximize our profit because we've been told that 25% of the marginal value on cost is being described as the profit to be realized from each belt type. So before we can calculate these profits, of which we'll calculate first of all the cost, and that's when we calculate the profit, we have to define what we call as the decision variables. Okay, so we're going to say that step number one in this case it is to define the decision variables. Okay, so where we're going to say that let x sub 1 be equal to the number of type A leather belts, x sub 2, that's the number of type B leather belts, and x sub 3, that's the number of type C leather belts. Okay, so step number 2, we can say determine the profit to be realized from each belt type. Okay, so how do we determine the profit? We have to calculate all the costs. So just use this table to gather some data. So I'm going to say that types of leather belts so we have x sub 1, got x sub 2, and x sub 3. Then we shall use the last column for available resources. Okay, now since we're looking at the cost here, if you look at the information that we have, we are told that the material cost for A is 700, B 520, C that is 300. Okay, so we'll start with material cost. So we have 700 here, and we have 520, and we have 300. Then we also had labor costs, which is 440, 360, and 260. So 440, then 360, and 260. Then we also had distribution costs. Distribution cost, we have a 60 for A, a 20 for B, and a 40 for C. Okay, so we have 60 here, we have a 20 there, and then we have a 40 for x sub 3. So going to find the totals. Well, we're going to say the marginal costs. So when you add for x sub 1, that is 700 plus 440 plus a 60, going to get a 1,200. Then for x sub 2, 520, a 360 plus a 20 there, that's going to give us 900. Then we go to x sub 3, where we have got material cost as 300, labor cost as 260, and distribution cost as 40. That's going to give us a 600. Okay. Now we are told that the profit there, it's supposed to be 25%, okay, of the cost. So we're going to say profit percentage. We have 25%. So that's going to be 25% of the 1,200, 25% of the 900, and also 25% of the 600. So our profit for each belt type, 25% of 1,200, we are getting a 300 here, and 25% of the 900, we are getting a 225. For x sub 2, 25% of a 600, we're getting a 150. Okay, so now that we have collected this data and calculated our profit, we now have to look at the variable resources. So we are told here that for us to calculate, also for us to produce each type of the belt, we are going to need these resources. Number one, we need leather. Number two, we need the fancy barcodes. Number three, we need we need the machining time. Now take note, we are told that for leather, the available resources per day, it is 900. For fancy barcodes, that is 400. Then for machining time, we are told here that it's 600 what? 600 hours. And these ones are parts. Okay. So let's look at this question very well. So type A needs 2 parts of leather and 2 parts of fancy buckles and the 4 hours of machining time. So here we need 2 parts of leather, 2 parts of fancy buckles, and then 4 hours of machining time. Then type B, it needs 5 hours. So it needs 5 parts of leather and fancy buckles each. Then 2 hours of machining time. So meaning we'll have 5 parts of leather and also 5 parts of fancy buckles, then 2 hours of machining time. Then the C, 10 parts of leather and 3 parts of fancy buckles and 2 hours of machining time. So meaning we're going to have a 10 here, then 3 here, and 2 there. So we need to come up with the mathematical model that describe this business problem that we have in this question. So after we are done with this now, our main step now will be step 3. So step 3, okay, we need to formulate the objective function. So the objective function basically outlines the aim, and of which we know that the aim of this is to maximize our profit. So we're going to say maximize Z being equal to, it will be the profit, okay, of X sub 1 plus the profit of X sub 2 plus the profit of X sub 3. So what do we do there? Shall say Z is going to be equal to, our profit for X sub 1 was 300. So we shall say 300 X sub 1 plus our profit for X sub 2, it was 225. Shall say 225 X sub 2. Our profit for X sub 3 was 150. So we shall say 150 X sub 3. Okay. Then step number 4 there, we are told that we define the constraints. So our constraints here, we know that it is, these are variable resources. Okay, so for leather, we need to come up with our constraints for leather parts, of which we can see that there are 2 for X sub 1, 5 for X sub 2, and 10 for X sub 3, which is supposed to be less than or equal to 900. So we'll say X 2X sub 1 plus 5X sub 2, then plus 10X sub 3 is less than or equal to what? To 900. Please take note that this is for leather. Okay. Then next, we have got fancy barcodes, which is 2, 5, and 3 should be less than or equal to 400 there. So I'm going to say 2x sub 1 plus 5x sub 2 then plus 3x sub 3 is less than or equal to 400. Okay. This is for fancy barcodes. Now, the last one there for machining time, we have got 4 for x sub 1, 2 for x sub 2, then 2 for x sub 3. So 4 for x sub 1 plus 2 for x sub 2 plus 2 again for x sub 3 should be less than or equal to 600. And this one, it is for machining time. Okay. Then step number 5 in this case, we look at the non-negativity conditions. Non-negativity conditions. Okay. This one, it tells us that the values, the number of each type of a belt, none of them should be a negative, meaning it's supposed to be greater than or equal to 0. So we shall say x sub 1, x sub 2, x sub 3 should be greater than or equal to what? Equal to 0. So now that we have formulated everything, okay, how do we write this now? So we're going to say, therefore, can present our answer like this, where we shall say maximize z being equal to 300 x sub 1 plus 225 x sub 2 plus 150 x sub 3. Okay, this is subjected to two x sub 1 plus 5x sub 2, okay, plus 10x sub 3 should be greater than or equal to 900. Then 2x sub 1 plus 5x sub 2 plus 3x sub 3 should be less than or equal to 400. Then 4x sub 1 plus 2x sub 2 plus 2x sub 3 should be less than or equal to 600. And the non-negativity, x sub 1, x sub 2, x sub 3 should be greater than or equal to 0.